In this lesson, we're going to be multiplying fractions and mixed numbers. Let's start with some fractions. Negative 3 over 5 times 11 over 12. The nice thing about multiplying fractions is that you do not need a common denominator. You are going to multiply the numerator and the denominator. But there is a shortcut. Instead of just multiplying straight across, meaning 33 over 60 and having to reduce big numbers at the end, I'm going to cross reduce right away. Cross reduce is looking across. So I'm looking at 3 and 12, finding the greatest common factor between the two. So between 3 and 12, the greatest common factor is 3, and that's what I'm going to divide out of both of those. 3 divided by 3 is 1, and 12 divided by 3 is 4. Now I'm going to look the other way, 5 and 11. They do not have a greatest common factor besides 1, so I can't simplify those two. Now that I cross reduce, I am going to multiply straight across. The numerator, 1 times 11, and the denominator, 5 times 4. A negative times a positive is a negative. Let's try, we're going to make some variables in here. Let's try c over 7 times 14 over 15. Just like before, we're going to see if we can cross reduce first. I see between 7 and 14, the greatest common factor is 7. I'm going to pull a 7 out of both of those. 7 divided by 7 is 1, and 14 divided by 7 is 2. Now I'm going to look across between 1c and 15. 1 and 15, the greatest common factor is 1, so I can't simplify those at all. I'm going to multiply straight across. 1c times 2, I'm working with the coefficient here. 1 times 2 is 2c. 1 times 15 is 15. At the end, always be careful to look at that fraction, 2 over 15, and check to see if you can simplify. This one's a positive divided, or positive times a positive, so our answer is positive. Let's try negative 2x cubed times, negative 2x cubed over 9 times a negative 3x over 4. Same process here. I'm going to ignore the variables at first, and I'm just going to check to see if we can cross reduce. Let's work with 2 and 4. The greatest common factor between 2 and 4 is 2. And the greatest common factor between 9 and 3 is 3, so I'm going to divide those both by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. Now I'm going to multiply across the numerators and then the denominators. This says, work with the coefficients, 1 times 1. Now we're multiplying variables. When we multiply variables, we add their exponents. So x cubed times x to the first is x to the fourth. The denominator is 3 times 2 is 6. A negative times a negative is a positive. The best answer here is x to the fourth over 6, but I would accept either answer. Let's try another one of those. Let's try negative 4x over 7 times negative 2x over 5. Push pause and try that now. I'm going to check to see if we can cross reduce, and I'm working with the numbers here. 2 and 7 do not have any greatest common factors. 4 and 5 also do not have any greatest factors, so we cannot cross reduce. When we're multiplying, work with the coefficients first in the numerator. 2 times 4 is 8. X times x is x squared. And then the denominator, 7 times 5 is 35. A negative times a negative is a positive. Check your fraction to see if you can reduce any further. We cannot. Let's try some mixed numbers. Negative 3 and 2 sevenths times 1 and 1/2. The downfall to doing multiplication is that you cannot multiply with mixed numbers. You have to turn them to improper fractions first. So here we have 7 times 3 is 21. 21 plus 2 is 23. 1 times 2 is 2 plus 1 is 3. Notice that the denominators stay the same. Now that I have improper fractions, I can cross-reduce and then multiply. I'm checking across for cross-reducing, and I see neither of them have a greatest common factor, so I'm going to go ahead and multiply. 23 times 3. And then 7 times 2 is 14. A negative times a positive is a negative. Okay, so our answer is improper fraction. It's an acceptable answer, but it's not the most complete answer. We're going to want to turn that improper fraction into a mixed number. So to do that, we think to ourselves, how many times can 14 go into 69? I'm thinking that 14 can go into 69 4 times. Yep, we get 56. So 4 goes into 69 4 times. And then there are 13 left over, and our denominator stays the same. Let's try another. Negative 3 and 3/5 times negative 1 and 5/9. You cannot multiply mixed numbers, so instead I'm going to turn them to improper fractions. 5 times 3 is 15, plus 3 is 18. 9 times 1 is 9, plus 5 is 14. Check to see if we can cross-reduce, and this time we can. It looks like we can take a 9 out of 18 and 9. And I'm going to multiply straight across. 2 times 14 is 28. And 5 times 1 is 5. Negative times a negative is a positive. I'm going to turn this into a mixed number. 5 goes into 28 5 times. There is 3 left over, and our denominator is 5. I'm going to do a couple more problems with you. At the beginning of the assignment, they have us working with exponents. Okay, think about what an exponent means. If you have 5 squared, you're doing 5 times 5. It does not mean 2/3 times 4. It means we're multiplying 2/3 by itself 4 times. So I'm going to expand this. And I'm just going to multiply straight across the numerators. 2 times 2 is 4, times 2 is 8, times 2 is 16. And maybe I'm going to do 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. When you multiply, you can multiply in any order. Check to see if we can reduce, and we cannot, so this is my final answer. They might have you multiply a whole number times a fraction. So we have negative 10 times 1/4. When you're multiplying, it's going to be easier to turn that whole number into a fraction. So turn any whole number into a fraction, you put it over 1. Looks like in this problem we can cross-reduce. I can take a 2 out of both of these. 5 times 1 is 5, and 1 times 2 is 2. A negative times a positive is a negative. There is a better answer here. I'm going to turn this into a mixed number. 2 goes into 5 2 times. That's 4. There's 1 left over, and our denominator stays the same. Last problem right here. You are going to be multiplying 3 fractions together. 2/3 times a negative 9/10 times 7/12. You have options here. You can multiply the numerators, all 3 numerators, 2 times 9 times 7 together, and then multiply the denominators together, get a really big answer, and then you're going to have to reduce. I suggest trying to reduce right away. Cross-reduce, that's the only thing you have to think about. So maybe I'm working with this 2 and this 10, and I see that I can take 2 out of both of these. And then maybe I look across here and I see I can take 3 out of both of these. Okay, now I'm going to check the other fractions. 5 and 7 have nothing in common, but what about 3 and 12? So I'm going to cross reduce with this fraction again. I'm going to take 3 out of both of these. Now I'm going to multiply straight across. So I have 1 times 1 times 7. And 1 times 5 times 4. A positive times a negative is a negative. A negative times a positive is a negative. And I can't redo 7 anymore.